Hello my dear students, welcome to the session. Last session we discussed the interconnection of energy sources, series and parallel combination of voltage source and current sources, right? We have seen certain important observation also, like any element which is parallel to an ideal voltage source that can be neglected, and any element that is in series with an ideal current source that can also be neglected. Yes or no? Okay. So let us look at now some important concept once again here. Before I put the title of this particular concept, I would like to ask you a simple question that how did we define the active element? What is an active element that we define? Active element is the one which actually supplies the power. Of course, more elaboratedly, we stated that it supplies finite power for infinite time. Okay, in a simple way we can say it supplies power. Okay, but look at this example and let's try to draw certain important points and important conclusions. There is an ideal voltage source which is connected across another ideal voltage source through a transmission line or a connecting wire which offers a resistance of capital R. Say this is V1 and this is V2. Okay. Now, what is happening here? A voltage source, ideal of course, another voltage source, both are connected across each other. Then what is happening here? If suppose V1 is greater than V2, then definitely current flows from higher potential to lower potential. And how much current is flowing? V1 minus V2 by R is the current flowing here. Yes or no? Then what is happening here? It looks like this particular source is supplying the power and this particular source is absorbing the power. Yes or no? For example, if this is a generator, what is the main function of it? It converts mechanical power to electrical power. Okay? A generator converts mechanical power to electrical power. But in this connection, both the generators are taken individually, but they are connected across each other through a transmission line. What is happening here? The first generator is supplying the power. That means it's converting mechanical power to electrical power. The second generator, it is absorbing the power. Okay, that means it is receiving the electrical power and it converts now into mechanical power. Temporarily, it is running as a motor. Though it is a generator, but temporarily it is running as what? Motor. Yes or no, all of you? But finally, what is the conclusion? That I have proven that even active element is also absorbing the power. But what is an active element as per the definition? Okay, in an interview, for example, you define an active element. Then you immediately say that, active element is the one which supplies the power. But suppose when you give that statement, if I give you the network in front of you, if I put it across you, then definitely the controversy will come. According to your statement, it supplies the power. But one of the sources is absorbing the power. So how do you justify? That statement, the definition of active element is correct. And this particular case is also correct. Yes or no? Then how do you justify it? How do you really justify that definition as well as this particular case? You understand? See, active element is the one which supplies the power. That statement is valid only for single energy source networks, not for multi-source networks. It is valid only for what? Single energy source networks. In case of multi-energy source networks, some sources may supply and some sources may absorb. I hope you understand the point, okay? So some sources may supply, some sources may absorb. In what case actually here? In a multi-source network. Okay? So that is why now we are going to actually discuss, okay, the important concept that power supplied or absorbed by energy sources. This is a very important concept and frequently you are getting some questions in GATE and other competitive exams, okay, on this particular concept. Okay, so first you write down the statement here, important statement. First you write down that. First you write down, all of you. First you write down. Active element is the one active element is the one that supplies power. Active element is the one that supplies power. Full stop. But this statement is valid only for single energy source networks. But this statement is valid only for single energy source networks. In case of multi-source networks, may absorb, but at least one source has to supply the power. Yes or no? If all sources are absorbing the power, then who will supply the power? There is a law called Telegen's law or Telegen's theorem. Okay, what does it state? It states that algebraic sum of the powers in the entire given network should be 0, or else the total power supplied must be equal to total power absorbed. Therefore, keeping in mind the Telegen's law, in a given network, at least one energy source has to supply the power. The remaining sources may absorb, or else they may supply. We do not know that. That depends on the network and how you are going to connect those elements. But definitely, some sources may supply, some sources may absorb, but at least one source has to supply the power. Okay? So how do you identify that? Okay, write down that. At least one source has to supply the power. In bracket, you can write Telegen's law. Now, how do you identify? For example, if this is a 10 volt source, then this is a 5 volt source, then obviously I can say that this particular source is supplying the power and this particular source is absorbing the power. Okay. Suppose, for example, I have a network with 10 volts, some 20 volts and 30 volts and some 40 volts. Okay. Which source is supplying and which source is absorbing? If I ask you a simple question, how do you answer it? I have a big network. This corner, let us say one source, that corner is another source, in the middle one more source. And it is a big network where there are so many passive elements connected. Just you can imagine the network. You can draw anything that you want. That's not a problem. Randomly you can place all the energy sources and then tell me which source is really supplying the power. Who is actually supplying? 40 volts is supplying, 30 is supplying, or else 40 supplying, these three is absorbing, or else which one actually happening here? To answer this question, I would like to make a small modification. You can easily answer now. I just make a small modification. Instead of plus minus, let me take minus plus. Now what is happening here? Who is actually supplying? 10 volts is supplying. 5 volts is also supplying. Now tell me, who is deciding whether that particular source is supplying or not? Supplying or absorbing? The value or the polarities of the voltage source and the direction of current? Who is actually deciding? You see, P is equal to V into I. That means the voltage and current product. Voltage means not simply the voltage magnitude, polarities are important. Current means not just simply current magnitude, but direction is important. So, if you have voltage polarities and current direction, if you know both of these, then only you can comment on power, whether that particular source is supplying the power or absorbing the power. You understand? Okay. Now, look at this. That is why we now discuss 4 important cases. The first case is that assume that there is a voltage source. Its value is V and the polarities are known. The current is, let us say, flowing in this direction. I'm just taking one case. The current may be in upward direction or downward direction. Yeah, single source network, I know definitely. Single source network, I told you already. Active convention, I told you that active convention you can define always only for a single source. In multi-source network, anything may happen. What is the active convention? I told you that if this is a positive value, then a positive current leaves from positive terminal. Yes, this happens, no doubt. Okay, but In case of multi-source network, I do not know which source is driving the current, which source is dominating over the other, and in which direction the current is flowing. I really do not know until and unless I am given a network. I have to see that network, I have to observe that network, analyze that network, then only I can comment whether that particular source is supplying or not. Okay? Then how do you identify whether the particular source is supplying or absorbing? Look at the active convention. What is that active convention is saying? If current is leaving from positive, then this particular source is supplying the power. Look at one more simple case here. For example, you take a resistor. Now definitely we know that resistor is absorbing the power. Yes or no? Yes. Voltage source is supplying the power. Definitely, because the single source network, there is no other option. This source has to supply the power. Now the current is leaving and the polarities are like this. The current is entering into positive terminal and this is absorbing. We already know that. Let us now relate them. In an element, if the current is entering into its positive terminal, that element is said to be absorbing the power. Got it? Now, we know that it is supplying. And also what is happening here? Current I is leaving from positive terminal. Let us relate them. The current I is leaving from positive terminal and we know that that particular source is supplying the power. Now based on this, I can say that in an element, if current is leaving from positive terminal, that element is said to be supplying the power. That's it. The simple example will give us a clear idea. Now in the first case, the current is actually shown like this. Then what is P actually here? P is equal to V into I. Now you need to mention whether it is a supplied power or absorbed power. Second one. In the same voltage source, I may have the voltage downward. Yes, just now we have seen in the first case, I have shown you, the current is entering into positive terminal. The current is also leaving from positive in this case, but entering into positive in this case. I told you there are two possibilities. The current may flow in upward direction or downward direction, especially in multi-source network. This topic, power supplied or absorbed by energy sources, has got a significance only in multi-energy source networks. We don't need to have this much discussion when we consider or when we consult single energy source networks. Yes or no? I think you got a clarity now. Okay. Now, look at this downward direction. P is equal to V into I. Current is entering into positive. I told you it's nothing but a passive convention generally. So okay, but it is going to be what now? Absorbed power. In passive convention we discussed always. Okay, the current is entering into positive terminal, then that is said to be absorbing the power. Okay. Now, in case of independent current source, we know current. We need to find the voltage. That voltage may have polarities. But how do you get the polarities? The polarities are plus minus or minus plus? Plus minus or minus plus? How do you get? Plus minus or minus plus? It depends on the network. We do not know. Don't comment based on the direction of current. In multi-source network, it doesn't work. In multi-source network, it doesn't work. In a single source network, I can say definitely, if this is a positive current, the current will leave from a positive terminal so that it supplies power. That is active convention. Active convention, whatever the statement you are giving, it is valid only for a single source network, but not for multi-source network. Therefore, I have two possibilities. It may be a plus minus V or minus plus V that I see in the next case. Okay. So what do you get here? Power P is equal to V into I. The current is leaving from positive, therefore I can say it is supplied power. Okay. Now fourth case, the current source now you have, and you have the voltage, let us say minus plus V. Then what do you get the power here? P is equal to V into I. Then this is actually absorbed power. Actually what? Absorbed power. Okay. But you also know that, don't write anything, I'll give you time, okay? You also know that in a particular element, in a particular element, if you know this is 10 amperes, the same thing you can show in opposite direction, it is minus 10 amperes. Yes or no? In a particular element, if you know this is plus minus 10 volts, the same thing you can write minus plus minus 10 volts. Yes or no? Keeping in mind the same here, let us apply the same thing here. Can I write the same thing here? Something like this. V, and this is what? Minus I, and then P is equal to minus V into I. Yes or no? V into minus I, that's nothing but what? Minus Vi. Okay? But what is this current doing? What is this current doing? The current is entering into positive. If current is entering into positive, you call it absorbed power or the supplied power? Definitely absorbed power. See, look at this. P is equal to V into I is the supplied power. But once I keep a negative sign in front of or before that value, let us say, then I got absorbed power. Therefore, if you say that there is an element which actually supplies 10 watt supplied power, you said this statement, then I said, no, it is actually absorbing minus 10 watt. I think both the statements are same. The statement given by you and the statement given by me, both are same. You said 10 watt supplied, but I said no, it is minus 10 watt absorbed. Both the statements have the same meaning. 10 amperes in this direction, minus 10 amperes in this direction. Plus minus 10 volts, minus plus minus 10 volts. 10 watts supplied, minus 10 watts absorbed. So for current, direction is important. For voltage, polarities are important. For power, whether it is supplied power or absorbed power, that is important here. Okay? So please make a note of it, all of these things. First you note down this circuit also. Okay, you have written already the statement, right? Okay, active element is the one which supplies power. Already I dictated some points. Note down this particular circuit also. Okay, then you take all these cases, then you come back here. Please note down all the points clearly. There are certain problems we are going to discuss. In further sessions, whatever I am discussing here, everything we are going to apply, and for every concept there are gate questions. Okay, I'm not just teaching just like that here. These are all important for gate and other competitive exams. Now let us see some examples. Let us see some examples. First example. I'm just note down all these problem examples. Okay, different examples. Different examples. We will see again in classroom workbook. There are some important problems which are asked in gate also, that we will see later. Now let us find the power supplied or absorbed by each and every element in each and every question here. Okay. Now let us try to find the powers. The first one, please note down here. Okay. Look at this. What is the power? minus 3 into 10, minus 30 watt. What is the current doing? The current is entering into negative, nothing but leaving from positive. If current is leaving from positive, it is said to be supplied power. If minus 30 watt is supplied power, then you can write it as plus 30 watt. What is it? Absorbed power. Clear? Now, coming to this particular problem, all of you look at this. Look at this. What is happening here? The current is leaving from positive or entering into positive. See, it looks like entering into positive. In current source case, you must see always this tip is leaving from negative. This tip is leaving from negative. Just now we have seen in the fourth case or third case, you have shown that current I plus minus V. What is this current doing? Is it entering into positive or leaving from positive? It looks like entering into positive. It is not entering into positive actually. It looks like that. You must be very careful in case of current source. In a hurry, you may do some mistakes. Okay, so be careful. The current I is leaving from positive. Okay, therefore it is supplied power. Now similarly, the current is leaving from negative, but nothing but entering into positive. Therefore, P is equal to minus 20 into 6 minus 120 watt. Okay. What is it doing? Entering into positive is nothing but absorbed power. But minus 120 watt absorbed power is nothing but plus 120 watt. What is it? Supplied power. You understand? This is very, very important. Okay. Then coming to the third one. Third example, let us find the power of each and every element. How do you find? Third example. Tell me, how do you get it? Tell me. 10 volts, right? For voltage source, you know the voltage, you need to find the current. How do you find the current? How do you find the current? Current through any path, what is the procedure? In that path, if there is a resistor, I told you in the last session also, okay, if that path consists of a resistor, you apply Ohm's law. If that path doesn't have a resistor, you go for KCL. Now this particular path doesn't have a resistor, therefore better you go for KCL. Now apply KCL here, the current is known here, but do you know what is the current? To know the current here, you must know the current here. To know the current here, you already know the voltage. How much voltage is there here? 10 volts. Now 10 volts and 10 by 1, 10 amperes, right? Okay. You already know the power also, 10 square into 100 watt. Okay. Now tell me, 3 amperes is entering and 10 amperes is leaving. Then how much should enter? Then this current should be 7 amperes so that the current, algebraic sum of the currents will become 0 to satisfy Kirchhoff's current law. Now you tell me what is happening. P is equal to, okay, 10 into 7, 70 watt. Is it supplied power or absorbed power? Current is leaving from positive terminal, that is supply power. Now what is the voltage across this current source? Because in case of current source, we know the current, we need to find the voltage. Parallel combination, you have an advantage to identify the voltage here itself. So 10 volts, now 10 into, what is the power here? Okay, P1, let us say this is P2. Now 3 into 10, 30 watt. Okay, what is the current doing? Entering into positive or leaving from positive? I told you already here, the current, the tip of this current source is leaving from positive. Therefore, it is supplied power. See, 100 watt, it is a passive element absorbed. There is no need to write in bracket for passive element. Anyway, it will absorb. But in case of active element, we do not know that element might be supplying or absorbing. But you need to mention it clearly. That is why supplied like that you are supposed to write. 30 watt supplied, 70 watt supplied. Okay, total how much supplied? 100 watt absorbed. Then power got balanced. Understand? According to Thelian's law, power must be balanced. Okay. So you note down up to this point, and this particular problem let us all do together. Okay. So please close that. Please make it fast. Make it fast. Now let's go with this particular problem. Okay. So tell me. Voltage source, we know the voltage, we need to find the current. But what is the procedure to find the current in any path? If the path contains a resistor, it is Ohm's law. If the path doesn't have a resistor, go for KCL. So it doesn't have a resistor, let us go for KCL. 10 amperes is entering. I need to know the current here. For that I require current here. Yes or no? For finding the current here, I know the voltage. Yes, how much voltage? 3 volts. What is the current? 3 amperes. If 3 amperes is leaving from this node, 10 amperes is entering. To balance the current, I mean some of the entering currents equal to some of the leaving currents. 10 amperes is entering, 3 is leaving, then 7 should also leave. I hope you understand the point. Okay. Now, the current is flowing in this direction. Look at this, it is proven that the current is also entering into positive terminal. That is why in a given network, you cannot decide the direction of current in the case of voltage source. In the case of voltage source, do not, finalize the direction of current based on the polarities. Never. In case of voltage source, do not finalize the polarities of the voltage based on the direction of current source here. Not like that. It all depends on, the given network. The current direction is to be determined. The voltage polarities are supposed to be determined. Okay? So be careful in this. Now the power. What is P1? 3 into 7. 21 watt. What is this current doing? Entering into positive. That means absorbed power. Now the voltage source plus minus. This is 3 volts. Okay. Then what is this? Power P2. 10 into 3. 30 watt. What is this current doing? Leaving from positive. That means supplied power. Now what about this? P3. 3 square into 1. 9 watt. 9 watt absorbed. 21 watt absorbed. Total 30 absorbed, but 30 supplied. Power got balanced. Okay. According to Telegen's law, the power must be 0. The net power must be 0. That means the algebraic sum of the powers must be 0. So please note down that. Note down that. Meanwhile, I'll give you 2 more here. Fifth example. Fifth example. Sixth example. Okay. The procedure to find this current can also be done something like this. Sometimes what you can do is, you can assume some current I. Direction is yours. That's not a problem. Let us see what will happen. You can assume some current. If your assumption is correct, you may get positive value. If your assumption is wrong, then you may get negative value. But the problem is correct. Assumption might be wrong because you do not know what assumption that you have to, what is the direction of current here. Only thing you are making an assumption here. Do not worry about that. You look at this problem. Now suppose if you take some current I, knowingly or unknowingly have indicated like this, let us say. Then apply KCL here. What will happen? I is entering plus I. 3 is also entering 3. Okay, I'm sorry, 10, right? Okay, 10 is entering here, 10. Then what is this 3 doing? Leaving. So what happens here? I is equal to minus 7. Minus 7 in this direction is also same as what? Opposite direction, how much it is? Plus 7 amperes. That's also correct. Therefore, do not worry about, okay, the direction of current assumption, your wish. You can start with an assumption, some current is flowing in this way. Start applying the Kirchhoff's current law and find that value. After finding that value, if you get negative, oh, you realize that the assumption is wrong. But the problem and approach is correct. Do not worry about that. Okay? But simply, it's a simple network. That is why I have directly taken 7 amperes. I clearly understand 10, 3, therefore 7. But in a complex network, I may not understand that situation. Therefore, let me proceed. Some I is flowing. Sir, why should I take I in this direction? I want to take I like this. No problem, proceed. That's it. That's not a problem. Similarly here, you can see. You can see. These two examples, note down quickly. This problem. In case of current source, we know the current, but we need to find the voltage. Okay. In case of voltage source, we know the current, we know the voltage, we need to find the current. But already these two elements are in series. So therefore, you already know how much current is flowing here, 10 amperes. You already know how much current is flowing, 10 amperes. Yes or no? So therefore, what is the voltage here? 10 volts. How did you find the polarities? Passive element, passive convention. Passive element, if you know the current direction, you can indicate the polarities. What is the power here? 10 square into 1, 100 watt. What about this power? 3 into 10, okay, 30 watt. What is the current doing? Leaving from positive supplied power. Yes or no? Say this is P1, okay. Say this is P3, okay. Now P2, let us say. To find the power of this, we must know the voltage across it. To find the voltage, okay, let us apply Kirchhoff's voltage law by taking some polarity, something like this. Okay. Sir, how do you know the polarities plus minus? I do not know the polarities. Multi-source network, I do not know the polarities. Not based on the direction of the current. Let us not indicate again. I'm telling you, the polarities are chosen randomly. Let us see what will happen. If my assumption is wrong, okay, I may get negative value. If my assumption is correct, I may get positive value. But my approach is correct, my problem is correct, my solution is correct. Look at this V. Okay, apply KVL. If you apply KVL plus V plus 3 and minus 10 is equal to 0, or else touching concept, you can apply V is equal to directly here. V is equal to touching negative minus 3, touching positive plus 10. So what do you get here? Plus 7 volts. Okay. If you have plus 7 volts, then P2 will become, okay, 7 into 10. This is 70 watt. Okay. See, I got positive value. That means my assumption is correct. But that I came to know only at the end of finding this value, not beginning of the problem. Okay. Therefore, supplied power, absorbed power here. Current is leaving from positive. Therefore, it is supplied power. 70 supplied, 30 supplied, total 100 supplied. and 100 watt absorbed. Therefore, power got balanced. Similarly, you come here. What do you get? Tell me. You come here. Current again here flowing how much? 3 amperes. Therefore, P1 will become what? 3 into 10. Okay. 3 into 10. 30 watt. Okay. Now, I want to find the voltage. Taking the polarities randomly, let us see what will happen. Let us see what happens. KVL must be satisfied definitely. To satisfy KVL, how much voltage must appear here we will find. Whether it is positive or negative, we will see after finding this value. Let us not unnecessarily break our head with respect to polarities, whether it is plus minus or minus plus. Don't investigate. Simply blindly take plus minus and indicate V, then find it, then we will realize later. Okay? Now, definitely to apply KVL, the voltage should also be known here, but you already know the current, 3 amperes plus minus. What is this? 3 volts. Now tell me what is V? V is equal to touch negative, therefore minus 10. Touch positive, therefore plus 3. Then what you got here? Minus 7 volt. See, I got negative. So what does it mean? My assumption is wrong. Okay, that means if I had taken minus plus V, then I would have got plus 7 volts. But is it not same? Plus minus 7 volts is same as minus plus minus 7 volts. Therefore, don't worry about that. Now you take the power P2. Okay, minus 7 into 3. Minus 21 watt. What is this current doing? Leaving from positive supplied power. But minus 21 supplied power is nothing but plus 21 watt. What is this? Absorbed power. And what about this? 3 square into 1, 9 watt. That's it. 9 watt absorbed, 30 watt supplied, or 21 watt absorbed. This is supplied, right? So therefore, total power got balanced. So please take down quickly here. This is how you need to solve, okay, and find the power, whether it is supplied or absorbed. You can easily, because almost all these examples are asked in previous competitive exams. Okay. So our flow of the lecture is something like this. I think by this time you might have realized that some concepts and relevant examples. Later we are going to see even some gate questions. Okay, don't worry about that. Still we are in first chapter, that is DC circuits, and the first topic in that is fundamentals of DC circuits. Note down quickly. Okay, so now we take another example here. Seventh one. It's very simple. What is the power? What is the power of this particular element? What is the power? Find that power, all of you. Find that power. Power, how do you find? Power of this particular element is asking now. As far as these two terminals are concerned, the current is leaving from positive as far as these two terminals are concerned, as far as this particular source is concerned. There is a potential difference minus 5 volts here. Yes or no? So what is this particular source which is connected here is doing? It is injecting the power. It is supplying the power. Because the current is leaving from positive, it is supplying the power. Of course, it is a negative power. Minus 5 into 2, minus 10 watt. But current is leaving from positive. Therefore, this particular source is supplying minus 10 watt. If this particular source is supplying minus 10 watt, then what is it going to do? This is going to absorb minus 10 watt. If it is absorbing minus 10 watt, it means that what? It is supplying plus 10 watt. Yes or no? This is how one way of, observation. But otherwise, better you take like this. What is the voltage across these two terminals here now for this particular element terminals? Okay, this is the source, right? The source value is how much? Minus 5. But as far as this element is concerned, what is the voltage? Minus 5 volts. Now, what is the current doing now? Is it leaving from positive or entering into positive? For this element, I am not talking about this particular source. I am talking about this particular element. What is it doing here? Tell me. Okay, this is entering into positive. P is equal to minus 5 into 10 minus 10 watt. It is absorbing power. Minus 10 watt absorbing power is nothing but plus 10 watt supplying the power. Okay. The source which is connected here is supplying minus 10 watt or is absorbing plus 10 watt. The element connected over here is absorbing minus 10 watt or supplying plus 10 watt. Clear, all of you? Be careful. We know the rules and regulations, but sometimes we may get confused. He is not asking the power of this element. He is asking the power of this element. Okay. Be careful. No doubt. Okay. So, I stop the session here and I will start discussing some more important concepts in the next session. Okay.